Let's solve the following linear inequality. So first, we will begin by considering each of the expression within the absolute values or within the modulus and equate it to 0. So first we'll take x minus 1 equals to 0. So this gives us x equals to 1. Then we will consider x minus 2 equals to 0, which gives us x equals to 2. And we will also consider x minus 3 and equate it to 0 to get x equals to 3. Now if we consider a real number line, and on this real number line we'll consider all the real values of x, and we consider x equals to 1, x equals to 2, and x equals to 3. So here we'll see that these three numbers divide the real number into 1, 2, 3, and 4 region. So region number 1, so there we'll have to consider all the values of x lying between negative infinity to 1. Then in region number 2, we'll consider all the values of x which is greater than or equals to 1. So here we are including 1 as well, but this is less than 2. Then in region number 3, we'll consider all the values of x which is greater than or equals to 2, but less than 3. And in fourth case, we are going to take all the values of x which is greater than or equals to 3. So we will study the nature of this inequality in each of the 4 regions. So let's begin. Starting with region number 1, so here we have considered x to be greater than negative infinity and it's less than 1. So here absolute value of x minus 1, so that will be equals to negative of x minus 1, which is 1 minus x. Absolute value of x minus 2 in this region will be negative of x minus 2, which is equals to 2 minus x, and absolute value of x minus 3, so that will be equals to negative of x minus 3, which is equals to 3 minus x. That means our inequality now becomes 1 minus x plus 2 minus x plus 3 minus x, and this is greater than or equals to 6. So we get 3 plus 2 is 5, 5 plus 1 is 6. So we have 6 minus negative 3x, so this is greater than or equals to 6. Now transposing 6 to the right hand side, so we have negative 3x greater than or equals to 6 minus 6, which gives us negative 3x is greater than or equals to 0. Now what we want to do is make the coefficient of x a 1. For that we'll have to divide both sides with negative 3, but we have a negative division by a negative number, so that means the sign of the inequality changes, and we have x less than or equals to 0 divided by negative 3. Now we know that 0 divided by any number is always 0, so we get x is less than or equals to 0. Now coming to our number line, so here we have considered that x lies between negative infinity and positive 1. So it starts with negative infinity and goes to negative 1. And here we have obtained that x is less than or equals to 0. So our 0 will be lying here to the left of 1. So here we'll have to consider the value of x which is less than 0. That means lying to the left of x equals to 0. So here we see that this is the common region, and this is the region that satisfies both x less than equals to 0 as well as x lying between negative infinity and 1. So that means our combined solution will be x which is greater than negative infinity, but this time it's going to be less than or equals to 0. So this is what we have obtained from case number 1 or region number 1. Now let's move on to the second region. So in region number 2, we have x greater than or equals to 1 but less than 2. So in this region, absolute value of x minus 1 will be equals to x minus 1. Absolute value of x minus 2 will be equals to negative of x minus 2. So that means it will be 2 minus x. And absolute value of x minus 3 will be equals to negative of x minus 3, which is equals to 3 minus x. Now our inequality becomes x minus 1 plus 2 minus x plus 3 minus x greater than or equals to 6. So here x and negative x goes away. So we have 3 plus 2, which is 5, and 5 minus 1 will be 4. So we have 4 minus x less than or equals to 6. So we will transpose 4 to the right hand side. So we get negative x greater than or equals to 6 minus 4, which gives us negative x greater than or equals to 2. But we want to make the coefficient of x positive 1, so we'll have to multiply both sides with negative 1. But in doing so, the sign of the inequality changes. So we have x less than or equals to negative 2. So this is what we have obtained. Now, if we look at a number line, so here we have -2, which is lying to the left of x equals to 1. So we are going a situation that x is less than or equals to -1. So this is the region x less than -2. And in our condition, we stated that we have to consider values of x lying between 1 and 2. So here, clearly there is no intersection between the two graphs or the two regions, which means that there will be no common solution. We cannot find a common solution or a solution of x that satisfies this second region. Now let's go to the third region. So with region number 3, we are going to consider the case that x is greater than or equals to 2 but less than 3. Then it immediately follows that absolute value of x minus 1 will be x minus 1. Absolute value of x minus 2 will be x minus 2. But absolute value of x minus 3 will be equals to negative of x minus 3, or simply 3 minus x. That means our inequality now becomes x minus 1 plus x minus 2 plus 3 minus x. So this is greater than or equals to 6. So here we have x plus x, which is 2x, and 2x minus x will be positive x. And we have -1, -2, so that's -3. So that simply gives us 0. So we have x greater than or equals to 6. Now we'll have to consider our value x equals to 6 on the number line. So we're getting a solution that x is greater than or equals to 6, whereas we have taken the condition that x lies between 2 and 3. Now clearly there is no overlap of the two regions. So here also we say that there is no common solution in region number 3 as well. So now we move on to the final region, region number 4. Now in region number 4, we have to consider all the values of x greater than or equals to 3. So that means absolute value of x minus 1 will be x minus 1. Absolute value of x minus 2 will be x minus 2. And absolute value of x minus 3, so that will be equals to x minus 3. Now we can rewrite our original inequality as x minus 1 added to x minus 2 added to x minus 3. So this will be greater than or equals to 6. So where we have 3x minus 6 greater than or equals to 6, which gives us 3x greater than or equals to 6 plus 6. That means 3x will be greater than or equals to 12. Now we want to make the coefficient of x1. Further, we'll divide both sides with 3, which gives us 3x greater than or equals to 4. Here you can see that the sign of the inequality has not changed because 3 is a positive number and division by positive number does not affect the sign of the inequality. So here we have obtained x greater than or equals to 4. So what we'll do, we'll consider x equals to 4 on the number line. We have obtained a solution that x is greater than or equals to 4. And from our case, we have x is greater than or equals to 3. Now clearly we see that there is an overlap of solution. So our solution will be, the common solution will be x greater than or equals to 4. Fine. So we started out with case number 1. So in case number 1, we obtained that x is less than or equals to 0. Case number 2 and case number 3 gave us no solution. And in case number 4, we obtain x is greater than or equals to 4. So that means our final combined solution will be x belonging to the interval -infinity to 0. So 0 is included. We'll use a closed interval. Union 4 to infinity. So here 4 is also included. We will use a closed interval. So this is a solution to the given linear inequality.